So today and tomorrow we're going to prove that triangles are similar. We are not going to prove them using a two-column proof. We're just going to explain why. So there's no proofs here. Remember, polygons are similar if their corresponding sides are proportional and their corresponding angles are congruent. Polygons are similar if their corresponding sides are proportional and their corresponding angles are congruent. Corresponding sides means little to little, big to big. Match up the lengths, not left to left, bottom to bottom, because they'll get flipped and turned and all that. So if I want to prove that two triangles are similar, I need to make sure that all three angles in one triangle are congruent to the three angles of the other triangle. And then the three pairs of sides are in the same ratio, they're proportional. So you have to do 6 things. Today you're going to learn shortcuts so you don't have to do 6 things. The first shortcut, the first way to prove triangles similar is by our angle-angle similarity. And if you want, you can just write what I have in parentheses there. Angle-angle similarity states that if you have 2 angles in one triangle congruent to 2 angles of another triangle, then the triangles are similar. You don't have to check sides. As long as you have 2 pairs of congruent angles, then the triangles are similar. So they're the same shape, different sides. Second way to prove triangles similar is by side angle side similarity. Works kind of the same way as our side angle side back in chapter 4. Triangle ABC, triangle XYZ. Shortest side 1 to the shortest side 4 would be the ratio 1 to 4, you agree? Longer side 4 to the longer side 16 would reduce to what? 1 to 4, right? Okay, so my sides are proportional, and then I need a congruent angle. That's what that A is standing for. Should I mark it as A, B, or C? What do you think? B. And I need it to be congruent to which angle? Z. So it's in that side angle side pattern. So your angles will be congruent, but the sides have to be proportional. That's how your side angle side similarity works. And then the third way to prove triangles similar is side 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 similarity, which is really what we've been doing this whole time, making sure that all the sides, corresponding sides, are proportional, short to short, long to long. For side angle side, yes. These are the only 3 ways that we're going to use today to prove triangles similar, or 3 shortcut ways. Recap quick here. Angle, angle. 2 angles of one triangle are congruent to 2 angles of another triangle, then these triangles are similar. They're the same shaped triangle, they're just different sizes. Similarity statement. Triangle TRS would have to be similar to, who does T go with? P. And R matches up with, and then S goes to F. Similarity statement, lining up the congruent angles. Side angle side, here's another look at it. If you have a pair of congruent angles, so A and D, and it says if the length of AB to the length of DE, so let's say AB is a length of 3 and DE is a length of 7, I need the length of AC and DF to be in the same ratio. So if I make AC be 6, how do I go from 3 to 6? Times 2. So what would DF have to be then so that it would reduce to 3 over 7? 14. I'd have to take 7 times 2. So then this gives me that side angle side pattern. The sides, short to short, long to long, are in the same ratio. Your similarity statement. Angle A goes with who? D. B goes with, and then it ends on F. Your questions today and tomorrow, a lot of them, you'll have to write your similarity statement. Make sure you're lining up the congruent angles. And then our last one, side, side, side. If all these sides are in the same ratio, 1 to 4, right? 2 over 8, is that 1 to 4? 3 over 12, is that 1 to 4? So they're all in that ratio 1 to 4. Then these triangles are similar by side, side, side. So my similarity statement, A, B, C to D, E, F then. So we're not really doing too much different. We're actually trying to shorten the amount of work by only having to check if it's the 3 sides, 2 sides at an angle, or angle, angle. Fish? Cool. First one. Given MX is perpendicular to AB, we have to explain why the triangles are similar and then write a similarity statement. What does it mean again if segments are perpendicular? They make right angles. So where MX intersects AB, they've given us these right angles. Whenever I look for similar triangles, I always try and find congruent angles first. I think the angles are easier to check than proportions. Do I have any congruent angles in these two triangles? Which ones? MAX, congruent to KBX. There's one pair of congruent angles. Do I have any other congruent angles? Julia? AXM and BXK. Would this be enough to say that this left triangle is congruent to the one on the right side?
Yes.
Yeah, which one of our 3 ways? Angle, angle. So when it says explain why, you just write angle, angle, similarity. Write a similarity statement. Triangle MAX is similar to, what's M go with? What's A go with?
X.
B. And X goes with X. I know you did. Alright, flip it over. Decide if those 2 triangles on number 2 are similar or not. Give me a reason why, and then give me their similarity statement. I think it's easiest to look for angles, congruent angles first. Then check sides. But however you choose to do it, I guess. Pop, are there any angles among these 2 triangles that are congruent?
Yeah.
Which ones?
ZVY and WVX.
Why are those angles congruent?
Because they're vertical.
Cool. Do you know if there's any other congruent angles?
No.
Good. So I know I can't use angle, angle.
Yeah.
So it's either side, angle, side, or side, side, side. Can I eliminate one of those other 2 right away? Side, 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 because how many pairs of sides do I know? 2, and I need all 3. So potentially, it could be side, angle, side if our sides are proportional. I'm going to start with 18. On my tiny triangle, is 18 the bigger or the smaller 2 sides? Bigger. So should I go with 24 or 36? 36. So we're going to write 18 over 36, which would reduce to 1/2. Good. Then check your other ones. 12 would correspond with 24. 12 over 24 reduces to 1/2. So are my 2 sides proportional?
Yes.
So are my triangles similar? Okay, this would be my explanation. Side, angle, side. And then my similarity statement. Ooh, if I do Z, V, Y. Who does Z go with? X. Good. V goes with V, and then Y goes with W. Most of your questions today will be like 2 parts. Tell me how they're similar and give the similarity statement. Make sure you have 2 answers for most of them. Good on that one? Cool. Number 3. ABCD is a parallelogram. We have to find the length of WY. I'm going to give it a variable, little e. We're trying to find the value of little e here in this picture. What do you think? What could we do? Any ideas? We could find little e. like all writing? What are you writing down that you can't say out loud? Touche. Riley, what are you doing over there?
Writing down the proportion.
A proportion. Cool. You guys, those of you that are still writing, you think proportion sounds good? Cool. Well, the proportion would work if the sides were proportional, right? Do I know if those sides are proportional or not? How could I figure out if they're proportional? What would I have to determine about the two triangles first? That they're similar. I gotta make sure my triangles are similar before I set up a proportion. Would it work to use side, side, side? No. Would it work to try side, angle, side? Do you know two sides in each triangle right now? Okay, so can I use side, angle, side? No. So what's my third one I have left over? Angle, angle. Clean your ears. I need a pair of congruent angles. Do I have any? Where? At W, my vertical angle. Do I know if any other angles are congruent? Which ones, Grant?
Alternate interior angles along the transversal ZX or AY.
Good. It's a parallelogram, the lines are parallel. So if I use AY as a transversal, then angle Y would be an alternate interior with angle A. So now they're congruent. So then my triangles are similar by what? Angle, angle. Riley, now that the triangles are similar, what can I set up?
Proportion.
Killer, now I can set up a proportion. I just like to start with the unknown. You don't have to, it doesn't matter. But E in this bottom triangle, does it go to 5 or 4? Should go to 5, right? Because isn't E marked between 1 and 2 curves? And see how W is on that same side, 1 and 2? So I would say E is to 5 as 10 is to 4. You can cross multiply right away. If you want to simplify, it would simplify to 5 over 2. 2 times E. 5 times 5. 25. Divide by 2, and what does E give us? 12.5. And you should have got the same thing even if you did not simplify. It's your choice to simplify first if you want to. So you gotta make sure the triangles are similar before you set up your proportions. And sometimes that helps because you mark your angles so you can find what sides go together. Okay, try the next one. Explain why those triangles are similar and then give me a similarity statement. I like to look for angles first. Sorry, fuzzy over there. Brad, do we know if any angles in the first triangle are congruent to any angles in the second triangle? Cool. So it can't be angle, angle, nor could it be side, angle, side. So that only leaves us with side, side, side. So we just need to check that the sides are proportional. Brad, 8 in that first triangle would correspond with what? 6. Cool. 8 over 6 reduced by 2, did you get 4/3? Yes, okay. And then 12 in my first triangle would have to correspond with what? 9. Those are the longer sides. 12 and 9, I can reduce them both by 3, and that would also give me 4/3, right? Do I really have to check 8 to 6 again? No, we already did it. So are these triangles similar? Okay, what's our explanation? Side, side, side similarity. Triangle E, G, F. What kind of triangles are these? Isosceles. When you have isosceles triangles that are similar, you must line up the vertex angles, but then the other ones don't matter because all 4 of the other angles are the same. So in triangle EGF, who's the vertex angle? How about an ABC? C. So wherever G is, my C needs to go in the same spot. So it wouldn't matter if you said ACB or BCA, as long as G and C are in the same spot, because the other angles are all going to be the same. Questions on that one? Or isn't this easy? Should be. Trying to lessen your work here. Number 5, we've had a few of these already from previous worksheets. In sunlight, a cactus casts a 9-foot shadow. Looks like a Captain Hook cactus.
You drawing.
I'm drawing Peter Pan now.
Peter Pan versus cactus.
See his tights, how they're skinny on his legs?
What about his red feather sticking out of his hand?
Isn't that Robin Hood?
No, that's Peter Pan.
It's both. It's
Okay.
both. Come on, Miss Carol.
Sorry, we don't really watch that movie. Okay, this is not drawing.
Captain.
Alright, so my shadow casts a 9-foot, or my cactus casts a 9-foot shadow, and Peter Pan, who's 6 feet tall, casts a 4-foot shadow when we're trying to figure out the height of the cactus. Why does this go into this section when we've already been doing it? Well, because it says use similar triangles, and I'm going to show you where those are at. Our sun would have to be somewhere over here, since my shadows are on the right. And the sun is going to cast sun rays, which create our shadows. Captain Hook cactus is awesome because he's growing perpendicular to the ground. And Peter Pan is standing perpendicular to the ground. And then the sun rays create congruent angles with the ground. So how would these two triangles be similar? What? Angle, angle. Okay.
Are you kidding?
I'm not kidding you. That's where this is coming from. That's why they throw it into this section. Do you need to know that? Not really, because you can just set up a proportion from this without knowing the congruent, or excuse me, the similar triangles. I like to start with the unknown. You don't have to. X, the height of our cactus, is to what? 6. The height of Peter Pan, as, and I gotta come back, as 9 is to 4. Our numerator all comes from the cactus information. Our denominators all come from Peter Pan. Can't reduce this one, so I'm just going to cross multiply. 4x equals 54. Divide by 4, and what do we get for a height of our cactus? 13.5 feet. You do not need to draw a picture unless it says draw a picture. Okay, and that's your choice. But if you don't draw a picture and you keep getting these wrong, I'm probably going to suggest start drawing pictures then. Okay, because then you can see what goes together. Alright? I like some of your cactuses from here, cacti from here, they're nice. So, those are sun rays, dude. You don't really see them, but they're there. Number 6. How are those two triangles similar? Louder, Julia. Good job. Flip it over. We're not solving it. We're going to 7.
Yay. Thanks.
Do 7, A, B, and C. Do all 3 of these.
7.
We have like a time limit.
No. I just want you to do all 3 of these. Determine if the triangles are similar. If they are, tell me why. Give me a similarity statement. Go ahead and try all 3 of these. on this first one? Did you say they're similar? No? Why not? Okay, so if I go to check the sides, if I use 6 on the first side, is that the smaller or the larger of these two? Who would it go with on the other side? 9, right? Because that's the smaller. So then 6 over 9 reduced by 3 would make 2/3. And then I would check 8 to 12. Reduced by 4 and I get 2/3. Okay, so are my sides proportional now? So are we going to use side, side, side then? Side, angle, side. Where's my angle? At X, because they're what kind of angles? Vertical angles. Do you guys think they're going to hear on the recording? Okay. These would be similar by side, angle, side. Our sides are proportional, short to short, long to long. And then we have those congruent angles. Similarity statement. I don't know, triangle AXB, then you'd have to do CXD. Okay. Make sure you check small to small, big to big. It will be. Just keep repeating Morgan the whole time. Okay. B. What do you think, Jackson? Are these triangles similar?
I don't know, but 6 and 9 can go together. and
Right.
that's 2/3, and that's the same for 8 to 12.
Cool, so my sides are proportional.
Yeah.
Yeah.
Proportional.
So would side, side, side work?
No.
No, because I only know 2 sides, right?
There you go, Jackson.
Well, yeah, but Peyton, there's 3 other ways. There's 2 other ways left.
Oh.
Can't be that one.
No.
The other ones require angles. Do you know any angles, Jackson?
Just X.
Yeah, because they're what kind?
Vertical angles.
Okay, well those are the only ones I know, so it can't be that one. So I have to double check. You said the sides are proportional and I have congruent angles. Would they be similar by side, angle, side? Why not?
Because it's side angle.
Yeah, that's not this pattern. This would be like side, side, angle, or angle, side, side. Your angle's not between them. We're not allowed to use that one. So these are not similar. It says to explain. Don't write not enough information. That's not an explanation. You could write not side, angle, side, pattern. Or you could say need another angle or side. But these ones are not similar because they're not following our side, angle, side pattern. They have all the parts that make it, but not in the right order. Good job. Third one there. What do you think, Ross? Are these 2 triangles similar? What'd you say yes by? Which pairs of angles are congruent, Ross? Why is M congruent to X? Excellent. Alternate interior, your lines are parallel. I need another pair though, Ross. Because these are what kind of angles? Awesome. So for your third one, you should say they're similar by angle, angle. If I say triangle MRT, M goes with X, R goes with R, and then W. Mr. T. You know who Mr. T is? The A-team. Big black guy, he wears chains, he's got a mohawk, and he's a pretty fool. Yeah, this is recording. I'm gonna like go in and use iMovie and then like insert a picture of Mr. T there and then.
You should.
No!
You should.
Alright, let's go to 9 so I have enough time to explain this one. You'll see a couple of these the next 2 days. It says Joan places a mirror 24 feet from the base of a tree. When she stands 3 feet from the mirror, she can see the top of the tree reflected in it. If her eyes are 5 feet above, how tall is the tree? So my water bottle here, that's my tree. And then she walks back 24 feet and puts a mirror face up on the ground. And then she stands right here and she walks backwards until she can see the top of the tree in the mirror. And then she measures the distance from that point, or she has someone do it for her, to her feet, and she gets that to be 3 feet away. Okay, this creates similar triangles. Our trees are awesome in the math world because they grow grow perpendicular to the ground. And Joan is standing perpendicular to the ground. And then there's this physics law that says the line of reflection, when it bounces back, they create congruent angles. Thanks to physics, I know these angles are congruent. So I know these triangles are similar by angle. Okay? So now that I know that the triangles are similar, I can set up a proportion to find my missing side length. So starting with that one, just because I like to. The unknown, x, the height of the tree, corresponds with what? 5, the height of Joan, as
24,
is to,
3.
can I reduce that side? Yeah, wouldn't it just become 8 over 1? That's nice, what's 1 times x? That's 5 times 4, 8, 40. About, because they made reference to that they're measuring from Joan's eyes, and hopefully Joan's eyes aren't on the top of her head. So this is just a little bit shorter than 40 feet. Alright. Here's your book assignment for today. Sorry you didn't get work time tomorrow, you will. I'll take questions tomorrow in class over these.
Taking notes was so much fun.
I know, right?
Oh yeah, he was, wasn't he?
He what?
He was in Rocky as well.
Oh, was he? I
Yeah,
don't really
Silver
remember
Knight.
that.